Hello everyone, hope you all are doing well. So now we will start up a new topic, that is calculate maximum height and range of the projectile. Talking about the maximum height of the projectile. So the distance that is covered by a projectile from launching pad means origin or initial to the max height where its velocity is zero. Where its velocity gets zero is called the maximum height of the what? Of the projectile. Maximum height of the projectile. So let's move further. We are having using equation of motion. Here we will use equation of motion. Likewise, just wait. Like from this is a we are having, this is our launching pad, this is our maximum height. The maximum height from launching pad to the maximum height, launching pad to maximum height, we will calculate that, and the velocity is equal to 0 is called maximum height of the projectile. So using equation of motion, here we will use the second equation of motion. Previously we have using first equation of motion. So second equation of motion is 2as is equal to vf square minus vi square. Okay, vf square is equal to is minus vi square. Now as we know is done yesterday, that here a is equal to minus g, because acceleration due to gravity, but gravity is an upward side, means uh, behind from the distance from the gravity to the up one side to the height one, so it will be minus g. A is equal to minus g. We are here. After that we are having s at the place. S is a distance, but we are having height, so s will replace with height. Okay, after that third we are having vf, we are having final velocity is equal to vy, and vy is also is equal to 0 because maximum height is equal to 0. After that we are having vi, initial point. Initial point is equal to v dot sine theta. Just wait, v dot sine theta. Okay, now here we will change the values with this all. Like we are having 2, we put 2 in the place of a, we put minus g, in the place of s we put h. After that is equal to sign. Now vf square is equal to 0, so 0 square will be remain 0, so we are not writing the 0. After we are having minus vi square, minus vi square, we are having bracket v dot sine theta, bracket close, and it got square. Okay, now after that what will happen? After that, now here my 2 minus gh, it will be minus 2gh. Okay, now 2 is what 2 is doing, 2 is just multiplying over here, it will go there and it will divide. But before that, here the two signs of minus sign will cancel with this, minus sign will cancel with this minus sign, so we are having just positive 2gh v sine theta square. But now what we will do, will here we just having h remaining, h is equal to, and we open the square, so it will v square dot sine square theta upon, now there were 2g, so we put 2g over here. Okay, so this is our equation that that we find height. What happening? Yeah, so here we have find the formula of height, and we have proved that how we can take out the formula of height. Height is equal to v square velocity square sine square theta upon 2g. Now move to next to calculate the range of the projectile. So here says the maximum horizontal distance from launching pad to target point, means landing point, is called range of the projectile. Likewise, this is a line here, means from this one point to this one point. This is a maximum horizontal line between them, horizontal distance. Okay, so we are finding this. So let's move further. After that, as we know that Vx, here we will not using equation, here we will doing directly. Vx is equal to V dot cos theta, V dot cos theta into t, means time, with that with respect of time. So we are putting here t. Okay, and secondly, same equation we are having Vy is equal to V dot sine theta into time. Okay, now here we receive two equations. One is v dot cos theta into time, one is v dot sine theta into time. Okay, but now what we'll do here, we will change our t, but we are using the x1 because y1 is for vertical and x1 is for horizontal, so we are using x1 equation. So at the place of t, we know the value of t. T is equal to, yesterday I solved it, that t is equal to 2v dot sine theta upon g. Okay, now same equation we will put over here at the place of t. So Vx is equal to V cos theta. Now it will into, I should copy this one. Okay, so this equation I have put over here. After that, in the place of Vx we will put a sign of range, as I explained the day before yesterday's video, that there are the many signs of range of projectile. One is we are representing with x, one r, one rh. So here we are representing with r, that r is equal to, now here we are having v, one v this one and second v this one. Now this v and v when combined together, so we are having v square. Okay, v square. After that we are having cos theta and sin theta. Here 2 is also remaining, so after v square we put over here 2. Now cos theta and sin theta is remaining, so we put cos theta and dot sin theta. Okay, we also multiplied it, cos theta sin theta dot cos theta sin theta. Now upon, in upon we are having g remaining. Okay, after that we move next, that there is one thing we should know, that 2 cos theta and sin theta is equal to sin 2 theta. Okay, this is equal to sin 2 theta. So here we will put over here r is equal to v square upon g, wait, v square sine 2 theta upon g. Okay, here so r is equal to v square sine 2 theta upon g. Okay, so here we have received our, what, here we have received our formula to find the range of the projectile, how to calculate the range of the projectile. Now last we are doing the maximum range of the projectile. This is a simple range, but if we have to find the maximum range of the projectile, so how we can find that range of the projectile? So to find the maximum range of the projectile, here we are having, we know that sine 2 theta is equal to 1, and when sine 2 theta is equal to 1, where it is equal to 90 degree, where an angle is equal to 90 degrees, so sine 2 theta is equal to 1. Okay, so here we are having sine 2 theta. Okay, so what we will do, that I will put here 2 theta is equal to, it means 2 theta is equal to 90 degree. Okay, after that, now 2 is multiplying over here, it will go there and it will divide, so theta is equal to 90 upon 2. So when we will divide that, so we have received an angle that is equal to 45 degree. Okay, then theta is equal to 45 degree. It means the maximum range of the projectile is 45 degree and minimum is 15 degree, as I told you in last video. Okay, so after that, if we want to find the maximum, so the formula, the definition of this is that maximum distance covered by a projectile at an angle of 45 degree is called maximum distance. Okay, after we have to make the formula of this. Okay, so we already know that r is directly proportional, means range is directly proportional to what? Range is directly proportional to sine to theta. Okay, so at the place of directly proportional we put a constant, that is r is equal to v square upon g into, here will come, wait, into sine 2. Now at the place of theta we put that theta of 90 degree, so we put 90 degree. Okay, now when we multiply, not 90 degree, sorry, by the way, I will put 45 degree because of maximum angle. After that, 45 multiplied by 2, again we are having 90, so I will put here r is equal to v square upon g, after that into, now no, nothing will remain because 45 multiplied by 2 we are having 90, so sine 90 degree is equal to 1. So we put here 1, so it will again multiply and we are having r is equal to v square g. Okay, so it's the formula to find the maximum range of the projectile. If someone says that calculate the range of the projectile if its velocity is 100 meter per second, so what we will do, if its velocity is 100 meter per second, so we will just put a range value, means r is equal to, now it's saying that 100 meter per second, so the square of 100 is 10,000. Okay, 10,000, because here velocity is double and gravity we are having 10. When it will divide with, so we are having r is equal to what? R is equal to 100 meter. Okay, so here we have find the maximum range of the projectile. Hope you understand today's lecture. Thank you so much for listening.